All right, hi everybody. Welcome to Electronics 101 for cosplay, safety, vocabulary, and good practices of wearable electronics. An introduction, just so you know what my qualifications are and who the heck I am. My name is Emily. I am a systems engineer, master's level cosplayer, one of our cosplay guests here at MAGFest this weekend, one of the cosplay guest judges tomorrow. So if you want to compete, go over to Hall E right outside at Cosplay Repair and go sign up. I'm also on the swag team here at MAGFest and arcade staff, so I wear a lot of hats, and right now I'm wearing my panelist hat, so welcome, thank you. Here are some examples of the work that I've done with electronics in cosplay. You'll recognize the swag from MAGFest 20. Who got a swag this year? Who doesn't know what a swag is? So a swag is a bespoke gaming system that we design every year for Super MAGFest. It has 6 games loaded on it, a bunch of utilities, metronomes. It flashes along to music in the concerts. It's really neat. You can get one at the Fangamer merch booth at the back of Hall C for $49. So they're really cool. You should get one. I've built a Sheikah slate, which is the 4 other photos on this slide. It's got an Arduino dropped on a custom control board, and it obviously has the giant screen. It draws the screen, it plays music. What else does it do? I don't even remember. It's been a minute. Oh, it's got an SD card it's got videos and photos loaded as well as music, so. That is slow. All right, so today we're first going to talk about safety because safety is important. Then we're going to talk about jargon, and I'm going to throw a lot of words at you. I'm going to move a little fast, and I'm really sorry about that. I like these pros up at the front with their notebooks. I really appreciate that. Yeah, I got to take notes for everything too. And we're going to talk about how do you look for help? How do I Google this? How do I communicate the problem that I'm experiencing with my prop such that I can get actual helpful information? And then I'll give you some recommended resources at the end. Did this? Oh, okay. It did cut out. Okay. Thought I was losing my mind. For books, videos, resources that you can turn to next now that you can speak this language. All right, so first, safety. It's my understanding that a lot of people are hesitant to get into electronics because they're terrified they're going to get shocked and die, right? And I'm here to acknowledge that that's a reasonable concern. However, explain to you why it's probably not going to happen and arm you with knowledge to protect yourself such that you do not do that on accident. So, the human body conducts electricity. That's why we are nervous around electronics, and that's why we wear things like ESD bracelets and rubber gloves and things like that. Electronics can burn you. They can burn your retinas. They can vaporize your hair. They can, this is horrible, can cause internal issue damage, apparently, cause interference with your heart, or it can kill you. Aren't you excited? There's a common phrase that is voltage hurts, amperage kills. Yeah, really. I don't like you. I'm going to switch. What?
How much electricity are you getting?
A lot.
It's the dead zone in the middle. That's why the motion is.
Yeah, that makes sense. Okay. Anyway, so you need enough of both for it to really, really hurt you. You should still respect the things that you're working on. You should always use isolating techniques to protect yourself when working with electronics. This is killing me. I'm going to switch to a wired mic. Give me 1 second. Now I did it. Woo! Anyway, where did my clicker go? There it is. Anyway, use isolating techniques to protect yourself when you're working on electronics, such as power adapters that are appropriate for your plugs, or just unplug it. Unplug your batteries when you're trying to mess with something or fix something. So, we'll talk about batteries first. Batteries can burn you. They can explode. They can leak nasty chemicals. It's really easy to avoid these things, though. So to be safe with your batteries, isolate your positive and your negative terminals, your reds and your blacks, your plus, your minus. Literally just tape them up. Not together, separate. Use just a commercial USB lithium power pack. Then you don't have to mess with your wires. It's like my power bank right here for my phone, right? You can make a hard case. That's really loud. You can make a hard case for loose lithium pouches. You can avoid overcharging or over-discharging your lithium batteries. Please don't leave them out in the cold. Don't leave them out in the sun because you can cause a fire. And lithium fires are very dangerous. Take your batteries out of your costume when they're not in use. We've all had a toy growing up that had the world's oldest AA batteries in it that were corroded inside the toy, right? And just take them out. You're not going to drain them, and the next time you want to use your costume, it's not going to be all gross and acidy and disgusting. All right. We're going to talk about PPE, personal protective equipment. So when you're working with electronics, always wear eye protection. You got glasses, just wear them. You can use safety glasses. You can use a face shield. When soldering or melting plastic, a mask. And consider an anti-static bracelet and a grounding cable. Those come in most beginners' electronics kits. Consider buying things like non-leaded solder. Solder has lead in it because it makes it really, really easy to solder. The problem is lead's not good for you. So there is non-leaded solder, or just wash your hands. You can wear rubber gloves. You can use air filters with carbon filters. There's a lot of ways to protect yourself and prevent yourself from inhaling nasty fumes, or just, having a really sweet finger after your project. You should know where your fire extinguishers are. Do you know where the fire extinguishers are in this room? They're right there. It's always important to know these things. So what happens when you puncture a battery? Anyone ever do this? Thank you for being honest. We're going to watch a video. If it will play, please play. Well, that's embarrassing. Anyway, so the long and short of it is it explodes. And it's super cool and fun and scary. I experienced a lithium battery pack fire back in June. I'm terrified of batteries. So it was a much larger battery pack, one that would go in like a car, right? It was in the back of a Toyota Highlander. It went up in 30 seconds, and the entire car was charred out. I inhaled the lithium smoke. I had to be treated by paramedics. It was very, very scary. Okay? I need you to understand electronics can hurt you in weird ways, and you need to be safe and respect them. And don't put a nail in a lithium battery pack. All right, so we're going to play a game. We're going to look at this photo, and someone's going to raise their hand or just shout it out. I don't care. Is this safe or unsafe? Really look at the photo, look at the details. Do you think this is a safe electronic setup? Why not?
It's unsafe because the connectors are out in the
Yeah, there are a lot of exposed contacts there, aren't they? And depending on the application, someone could start sticking tweezers or whatever in them. Generally, I consider this to be safe, but I think you brought up a really good point that those soldered connections, especially for the batteries, should be maybe taped over or glued over.
Yeah, I figured this was the finished stage, then you
For sure.
put this in like a case or something.
Yeah. I liked this because it has a case for the batteries, right? It's a nice hard case. All the wires are neatly organized. Things are just neat, right? What about this? No. Oh yeah, you can do that. That's totally legal. No one can stop you. You ever? How you desolder it? Yeah, don't. This is unsafe because the leads are obviously exposed, right? We want to isolate. Do something like this. Put something like tape or heat shrink or whatever over it, right? How do you feel about this battery? What's wrong with it? Yeah. Any of you ever have a Galaxy Note 3? Yeah. If your batteries look like this, dispose of them properly. Don't throw them in your trash. You go to a battery recycling center. Do not put them in your trash because that poor trash man, when he dumps your crap into his trash truck and it munches it, it's going to boom, and then we'll pray for him. You probably don't need to do that. To put out a lithium battery fire, all you need is a shitload of water. I don't remember. Oh, it does. Yeah, a shitload of water. Yeah, it does. So when I experienced that car battery fire in June, we removed the battery pack and dunked it in a very large, like, shipping container size tank, and it put the fire out. So if you ever do experience this, dispose of it properly, but water does put out a lithium battery fire eventually. My computer is just chugging tonight. So yeah, if it goes up, call 911, get out. But if you've got a bucket of water handy, and you're somehow capable of placing it in it, go for it. It's a really wise decision. Who has done this? I just did it like last week. Don't do it. Like it's just don't. I have nothing more to say about this. All right. Our guy is soldering. He's working on some electronics. What do you guys think about this? Unsafe. Why? He's not wearing his PPE. Wear your PPE, guys. Solder can, I don't want to say explode because that's not accurate, but it can splatter, thank you, and get in your eyes, get on your face. The fumes from the soldering and the flux aren't good for you. Just wear a mask, wear glasses. All right, we're done playing games, and now we're actually going to learn. Hooray. What's that? So for a lithium battery pack, like I said, just put it in water, let it cool off, call the fire department. They'll get rid of it. For most other batteries, like I said, take it to a recycling center. Most other batteries don't have a ton of energy in them, and they will burn themselves out. Fire extinguishers are always a good idea. They're not particularly effective on lithium fires. But I seem to recall we emptied 12 5-pound fire extinguishers on that battery fire in June and didn't even flinch at it. Yeah, so Class D fire extinguishers are for metals like magnesium. This is not the same type of lithium, because it's a lithium polymer. Yeah, it certainly won't accelerate it or anything. So, any other questions? Google. I'm sorry. Most towns have battery collection, and either through your municipality or there's retail stores I can't remember the name. Yeah. I'm confident you can find one fairly easily that way. All right, any other questions before we move on? No? Great. Okay, we're going to talk about vocabulary and jargon. If you don't know these terms, I will be speaking a foreign language, but that's okay. That's why you're here. So we're going to compare electricity to something that we can actually see and observe. The flow of electricity is like a water hose. You have voltage, which in this analogy is the water pressure. Current, which is measured in amps, is the diameter of the hose, the size of the hose. If you have a very large, high current path, it's a big, fire hose, right? And resistance is the stuff inside the hose that is obviously preventing it from moving forward, whether it's sand, whether you got a kink in it, whatever. We're going to be using the water analogy a lot with this, and I'm hoping that will help you guys understand what's happening, because we can't see the electricity flowing, right? If it would advance to the next slide. There we go. So a watt is a power unit. Power is a measurement of energy over time. So many electronics have 3 ratings for power. Max wattage, the ability to handle a certain power input or output. Like you have a 400 watt power supply in your PC at home, for example. Max amperage, the ability to handle a certain current. So you may have a 400 watt, 60 amp power supply at home, right? And the max voltage, ability to be powered by a certain voltage source. This is, let's say your power supply at home is a 120 volt power supply. It receives 120 volts out of the wall. Or it could be a switched 120, 240, whatever, right? You need to be under all 3 of your maxes for your application to be safe. Let's say you have a light that's a 60 watt light bulb and it requires 12 volts. If you try to give it 24 volts, it's going to blow up, even if your total power may be under 60 watts. Conveniently, we're going to do some math. Wattage is equal to voltage times amperage. It's very simple math. All right, batteries. They're described in 2 ways. One, their voltage. You got the 3.7 volt, you got your 9 volt, you got your 12 volt batteries, right? And that voltage is at its nominal charge. Maybe not its maximum charge, and certainly not its minimum, but what you expect it to output when it's working correctly. You also have its capacity in milliamp hours. So in the previous slide, we talked about amps, current, right? Milli, because it's small, in hours. It's a multiplication of amps times hours, okay? So if I have a lithium battery pack that is a 3.7 volt pack, that's very common nowadays for hobby electronics. It is 2,000 milliamp hours. So it operates at 3.7 at its nominal voltage range, even though it may be able to charge up to maybe 4.2 or so, and it can discharge down to 2.7. It generally hangs out in that 3.7. And it has 200 milliamp hours of capacity. Any questions on batteries before we move on? What's up?
So for capacity, that tells you how long it can run at its expected?
Yes. So if you have a circuit that draws 500 milliamps and you power it with a 2,000 milliamp hour battery, you divide 2,000 by 500, you expect 4 hours of use. Generally, it's going to be lower than that because the batteries aren't very efficient when they're super high charged or super low charged, but it's a gut check. Okay. So, and did anyone else have a question about batteries? No. Okay. So, buttons, switches, and toggles. They are described with poles and throws. A pole is the number of circuits that are controlled by a switch. And the throw is the extreme position of the actuator. Whether you have one up, and that's one throw, and then one down, that could be one throw. You could also have a switch that rotates and it clicks, and each click is a throw. When you go and look for a switch, they are described as a number P and then another number T, like a 1P, 1T, one pull, one throw. Usually X and Y in this example are single or double. You'll see an SP, ST for single pull, single throw. It's the same as one. These are some examples of some switches. Can anyone tell me the one on the left? What kind of switch would that be? Oh, sorry, with the pulls and the throws. It is. It's a single pull, single throw. What about the second one, the one in the middle? Single pull, double throw. That's right. Because you have one up and one down, that's two throws. But it's single pull because you're only connected to the battery in the middle, right? Yep, there's only one source. Yep. And then what about the one on the right? It looks like a double pull, single throw, because there's only two positions, right? Even though it's engaging two different circuits, it's only one throw, right? Yep, double pull, single throw. Is that what we said? Yeah, sick. Okay. Sometimes they can get a little confusing. There's a couple of different types of buttons. You don't just have the toggle on-off switches, right? You have momentary switches where you push it and only for a moment it engages the circuit. You can have toggle switches. It usually holds its state when it's actuated. It's like a light switch, right? And then you have rotary switches, the one that I was talking about, where each click is a different pull. Or, sorry, a different throw. Jeez. Any questions about switches before we move on? Good. All right, resistors. Resistors convert electricity into heat. They are used to control power input to a node because they convert electricity to heat. They dissipate electricity, and they limit the amount of power that's going across the resistor to whatever's on the other side, right? They drop voltage across them to dissipate energy. So if you measure on one side of a resistor and the other, you will see what's called a potential difference, or just a difference in voltage. That's all. The units of a resistor are ohms. Ohm was a guy. I don't know anything else about him except that he has a law. Sorry. My electrical engineering professors would be very upset with me. And the strength of resistor is called impedance because it's impeding the flow of electricity, or resistance. You can see either of those terms online. Impedance is like the posh scholar term, but it's either. Resistors can have a constant impedance, or they can have variable impedance. Trimmers, or potentiometers, are adjustable impedance resistors. They're useful in things like adjusting power. They're dimmer switches on your lights. If you want to speed a motor up or slow it down, this is when you'd use a potentiometer or a trimmer. And some are sensors, like light sensors are actually just resistors reacting to a light source. There's other types, so I don't want to confuse you. But the light source is very common in cosplay, like when you flip up a mask and a light turns off, for example. Some types of resistors have markings on them to be used to decode what the value, the impedance of the resistor is. Shown here is one with color bands. Sometimes they have a code, like a 3-digit alphanumeric code for you to find out what the resistance is. But these are the most common, especially in beginners electronics kits. So resistors are important in your cosplays because they limit the power input to the rest of the circuit. When you use them properly, they can help you conserve battery life. They can protect your components and yourself, and they can reduce the amount of heat in the system. So let's say you're trying to power an LED, right? And you have a 12-volt battery. If you don't use a resistor, that LED, it's going to be really bright, and it's going to get really hot, and it's going to drain your battery super quick. But if we look at the device's power requirements, watts, amps, volts, we can determine the size of the resistor that's necessary for your application. P equals VI, power equals voltage times amperage. That's what I mentioned back at the beginning of the slides, right? We also have voltage is equal to current times resistance. That's Ohm's law. These two equations are very simple, and they can help you do most of your simple cosplay props.
So it sounds like buck converters and resistors kind of serve the same purpose.
Yeah, so buck converters, the benefit of those is that they do voltage, I can't find the word, conditioning. Yes, and they have more advanced circuits on them to either boost or buck, increase or decrease voltage output. You can't use a resistor to increase voltage output. You can do it technically to decrease, but it's really inefficient. Buck converters are way more efficient, and I would recommend if you need to step down like 12 to 3 or something. What's up?
Sorry, I just want to double check what I is amps.
Yes. That's why I color coded them, so you can follow. It's kind of hard to see with the light. Anyway, anyone else have a question? Nope. All right, capacitors. Capacitors store charge in order to maintain a voltage level at a node. While resistors dissipate voltage, capacitors maintain voltage. The units of a capacitor are farads. A farad is huge. So most capacitors are in microfarads and millifarads. Again, some of them can be a fixed capacitance and some can be adjustable. Many capacitors, but not all, have poles. a positive and negative, very similar to a battery. So capacitors are useful in applications that require a lot of power input very quickly to a circuit. For things like spinning up a motor, turning on a bunch of lights. I'll think of another example eventually. It's gone. Anyway. I had it right there, you know what I mean? They are useful for maintaining a voltage if there's like an intermittent connection or if there's like a pulsing in your circuit. If you've got like an LED that's really bright and using a lot of power and you're turning it on every half second, you got like a timer or an Arduino or something, you can put a capacitor on one end of that LED and it will help maintain that voltage such that you don't completely annihilate your battery and completely draw too much current at one time, just to get it back up to that voltage level. Like I said before, they can be compared to batteries. They're not quite the same thing as batteries, and they have such little capacitance compared to a battery. However, you can look at capacitors as teeny, teeny, tiny micro batteries that are maintaining a small voltage difference for a remarkably short amount of time. Any questions on capacitors? They can be made out of a bunch of things. Certain like ceramics. Let's see. I think it's on here. Yes. I don't know how to explain half of those. Like I don't know what an electrolyte capacitor is actually made of on the inside, but magic smoke, crystals. Crystals is a real answer. I swear to God. What was your question?
Just going to ask, don't some original Xbox models actually use an internal clock capacitor?
Yes.
So when you mentioned the intermittent connection, so that's like you have something that goes on and off with a button.
Mm-hmm.
The next time you turn it on, it already has some stored voltage.
Just a teeny bit.
Directly from the battery again.
Yep. In certain situations, if you have a really high power draw we'll keep using the LED example, you may accidentally dip the voltage low enough that you turn your whole device off. I just experienced this at work. I was designing a prop gun. We make simulators like laser tag kind of weapons. We were turning it on and flipping all of our lasers on, and the voltage dipped low enough that we turned the whole device off. We were like, this is embarrassing. We added a capacitor and everything was fine after that.
I apologize if you already answered this, but are there any giveaways as to whether or not capacitors blowing out of water?
Yeah, so they explode. Yeah, I'm serious. Like, they blow up. Other than that, no, they get charred and melted, and usually they have opened at that point, or they just disappeared if they're like really, really teeny tiny ones on a circuit board. Anything else? Oh yeah, because it stinks. Yeah, you let the magic smoke out. Like, yeah, I wish I had a smarter answer for you, but they explode. Oh yeah, absolutely. They'll have a stench. Anyone else? Excellent. All right, LEDs and diodes. Diodes are devices that act like one-way switches and to send current to another location. So diodes, like some capacitors, have positive and negative poles. Light-emitting diodes, or LEDs, are only one type of diode. There's several types. Diodes are useful in protecting circuits from high current sources, sending current in a certain direction, or in a specific location, and more. So diodes are basically like doors that only open one way. And I don't know if you've ever seen perhaps a child or a dog run at a door that is a pull door, and they attempt to push it. That door is a diode, effectively, and that poor tiny creature is current trying to get there and knock down the door. It'll let it go one way, but not the other.
Are these good at making sure, like, if we accidentally put batteries the wrong way kind of thing?
Yes. So diodes can prevent reverse current flow, which can be absolutely detrimental to a lot of applications. They're common when using electric motors. What you want to do is make sure that you're sending current in only one direction and there's no leakage current, like a backflow down into your ground, because once you raise the ground voltage, it screws things up. Like, best case scenario, your circuit doesn't work, but you can cause maybe not a short, because that's not what it is, but putting voltage into your ground is rarely a good idea. Anyone else? So I've said a bunch of things, but haven't really given a lot of examples. So we're going to talk about one. That is so tiny. Well, oh well. So this is a very common cosplay prop example. You have a prop that you want to glow. You've got a battery and a light and a dream, right? So we've got our battery, we've got a switch because you want to be able to turn it on and off. We've added a resistor, and we have one LED. So let's assume the LED is red. LEDs, I should have added this slide. I'm going to make a note. LEDs have a certain forward voltage. That's the voltage, the minimum voltage that the LED wants from the source in order to turn on. If it doesn't see that minimum voltage, it will not turn on, no matter what. You can give it 1 billion amps. If you don't have enough volts, it does not care, because diodes are doors. So red LEDs have the lowest forward voltage because the wavelength of red is the longest, right? It doesn't require a lot of energy. So 2 volts and a forward current, which is just like a data sheet thing, of 20 milliamps, or 20 over 1,000 amps. This is important for the math. So we got a 5-volt battery pack. It's a USB. I'm powering it with this power bank, right? So the LED wants 2 and I have 5. How can I only give it 2? Or how can I limit the amount of power that I am giving this LED such that I am making an efficient circuit? A resistor. Good job. So to size the resistor, we do voltage equals amperage times resistance. We need 250 ohms. That math is wrong. Whatever. No, like the literal algebra is correct. It's not. Anyway, I don't want to confuse you. For the example, we're going to say 250 ohms. So we go to our little electronics kit with all the resistors, with the bands, and we look through our catalog for something that's close to 250 ohms. If you get 256 or 249, it's okay for this application. You just want to be in the ballpark, right? So we look for, if you could read this table, it's very tiny. We look for a code RGB because the table specifies, it translates the bands, right? It comes with your electronics kit. You can also Google this table, and it's completely universal. We look for something close to 250. And then all of a sudden, we connect them together, and look, we got a light. Okay, any questions about this before we move on to the next section?
If you don't put the resistor on it, is that like a fire risk?
It depends. That's a bad answer, but the LED will likely get very hot. It'll burn out the best case scenario, it gets warm. It'll burn out, you'll drain your battery, it's super quick. It's just not a great solution. Lots of off-the-shelf products like LEDs, sometimes they have an internal resistor. You just read the sheet that comes with it, so you know for sure. And adding resistance is never a bad thing, it just gets dimmer. So, food for thought. All right, so I told you a bunch of jargon and I gave you one example, and now you've decided I'm going to sit down and build my prop. How do I do that? Asking good questions on forums or even prompting Google is a skill, and it's okay if you don't know how to do these things. That's why you're here. So the XY problem is a common problem that tech people experience doing things like help desk or on forums when someone's asking for help and they don't know how to ask correctly. So in this, we have a person who's trying to get a balloon off the ceiling. That's the problem. Their attempted solution is to stack 2 chairs on a table. So this poor guy is like, I really want this balloon, and I don't trust these pieces of furniture, so I'm going to ask for tape, because then it's more sturdy, right? So he's in danger, and he's like, hey, person in the other room, can I have some tape? Where's the tape? I need tape. Please, tape. Help, tape. But that's not the problem. The problem is not that he needs tape. The problem is that his balloon's on the ceiling. So people will go on a forum, be like, hello, I need tape, because I need to get a balloon off the ceiling. And people will go, why? Why do you need tape? And it's not effective communication. So, in a more practical example, I scoured the Cosplay Help and Advice Facebook group for an example of this. I don't want to pick on the person who asked. I just thought it was a really good example, so I pulled it. They said that my cosplay came with this AA battery pack on the left, the little one. And I turned it on and it was overheating. So then I changed my battery pack and I turned it on and it was overheating. Can you suggest a battery pack? Do you guys understand? The train of thought makes perfect sense. They are troubleshooting. They have done things that they think might solve the problem. But the problem is not, give me a new battery pack. It's, my cosplay is getting very hot. Why? So in this example, they're probably experiencing too much current draw due to something like a short. Maybe they don't have a resistor and they got a bright LED, right? They're assuming that it's the improper battery selection. In this example right here, we got 4 batteries, and the other one we got 5. Rarely is that the problem. You're just adding capacity, usually, with these battery packs. You got to read the data sheet. So, what they could ask instead is, my battery pack is overheating. What should I look for? Please load. So, when you approach a forum of earnest and varied in skill cosplayers on the internet, boil your project down to simple concepts. This is a battery powering an LED light versus I am making a glowing sword. Because whether you make a sword or a helmet or whatever, ultimately it's a battery connected to an LED. You can communicate very, very specifically what your application is, such as this is an Arduino sending commands to a 7-segment display, blah, 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 versus clock radio. Both of them are technically correct. One of them's a little more useful in helping us diagnose your problem. There are many examples on the internet of an Arduino controlling an LED that is not cosplay. Use that to your advantage. So don't Google Terminator eyeball prop how to build if you got the mechanicals down, right? But if you're like, I want a red LED and a little thing and put on my face, that might be a little bit easier to find a solution. Show your diagrams and provide details. I'm using a 12-volt red LED versus LED. Maybe provide a link to it. Describe the problem that you're observing. Symptoms. Use your senses, right? Heat, smell. Can you hear anything? Do you hear like a whistling or a whirring that you didn't expect? And specify what research or testing you've done so far. Because there are some very unkind people on the internet who will assume that you're an idiot, and you're not, because you're doing something very complicated. You just don't know how to communicate that confusion. All right, so this panel is only going to get you so far. I just threw jargon at you for 45 minutes. I would like to recommend some resources. First, can everyone look under your seat for a Post-it? There should be 5. Yeah, it'll be right at the front. You got one. Hold it up when you got one. Nice, that's fine. Don't fight each other. We got one more. There it is. Come get a book. Come get a free book. Oh, sorry, there are 6. We got one more. I swear this is not like a paint 3 pigs situation. Okay, here you go. They're all mostly the same. They're the, yeah, help yourself. Here you go. Here you go. I don't need that back. You can throw that away. Here you go. I was hoping you would find one. Here you go. All right, one more. Anyone? You guys got to find it. It's an activity. Crawl on the floor. Get swifty. That's my PG version. Nice. Congratulations. I like your shirt. That's cool. All right. So, if you weren't fortunate enough to get one of those books, sorry, they're expensive. These are the books that I handed out today. Write them down, take a picture, go look for them. I own all of these books and can sincerely recommend them. Adafruit makes very good content, a lot of wearable electronics content. They sell a lot of products that are compatible with wearable electronics, including thread, conductive thread, and things of the sort. So, Kamui Cosplay has a lot of tutorials on basic electronics integration on her website. The Cosplay Help and Advice group on Facebook. And you can just send me an email. That's okay. I'll look at your circuit. I'll help you diagnose it. I'm trying to teach here, right? I'll let you guys write this stuff down real quick. And that is it for Electronics 101. I hope that wasn't too much. It's a lot of information, right? So I have several events going on this weekend. This is where I chill. Tomorrow, we got the cosplay contest, 3 to 5:30 over in panels 2. Then we have Taskmaster, where I'm a contestant. Taskmaster is a game show. You should really come. It's going to be a blast. Over in panels 2 at 7:30. Then we have the soldering workshop Saturday at 10 a.m. right here in this classroom. It's $5. You get a ticket 1 hour before the event, I think. Go ask Makerspace staff. I don't want to lie to you. Thank you. You are Makerspace staff. 1 hour before the event. So 9 a.m. Saturday morning. Shake off that hangover, if that is your poison, and come learn how to solder. 5:30 on Saturday, Electronics 201 for cosplay. And Sunday, 11:30 a.m., we will have a confessional where we will talk about the cardinal sins that I've committed with my 3D printer for cosplay. Oh, that panel's so fun. It's great. It's a great Sunday morning activity. Everyone's glazed over. What's up?
Are there any forums that you recommend searching for, like how you would Google, like site Reddit, try and get levels?
Right. Oh, man. I miss forums. I'm a child of the old internet. I wish I could recommend one, but I really don't have one. Sheeprop community on Facebook is very good. Just a lot of very helpful, kind, earnest people there. The Punished Props group on Facebook as well is pretty good. If you're not on Facebook, I don't really know. I'm sorry. Yes. Yep.
For the old school form, there's the RPF, I forget what it's called.
RPF, like Romeo, Papa, Foxtrot. Got it. I had to think about that one.
Yeah, I mean, it's not a lot of people in there, but it has really good advice.
Excellent. Thank you. Anyone else? Questions, recommendations? No? All right. Get out of here 5 minutes early. Thank you again.